a sector. How do you find the area of a circle? Pi r squared. Okay, then you have something called a sector fraction. Okay, or part of a circle. And the way to figure out what fraction you have is by taking the central angle and dividing it by 360. So if my central angle was 90, how big or how much of the circle do I have? 1/4, because 90 over 360 is 1/4. Okay, again, theta stands for your central angle. Okay, that is all it is like a variable. It just is a Greek symbol and it stands for an angle most of the time. Okay, it's the same thing as if I had x, a, b, c, whatever. Okay, it's just a variable that's a Greek symbol. Okay, so to find sector area, you combine the two. Okay, you take your sector fraction and you multiply it by your total area, which is pi r squared. Okay, because we are dividing by 360, what do you think your central angle needs to be in? Degrees. Okay. If you were to have put this in radians, what do you think your formula would be?
Theta over 2 pi.
There you go. I'm going to go this way. So if your central angle is in radians, you would have theta over 2 pi, because remember 2 pi radians goes around your whole circle, times pi r squared. Okay, the only thing you don't want to do is put angles over 2 pi, or sorry, degrees over 2 pi, or radians over 360. They need to correlate with one another.
We're given like a radian value, and you can change it to a degree and then use it to work.
You can always convert. If you're given radians, you can convert to degrees and then use just this formula, or you can leave it and use this one. It's up to you. Alright, let's practice. Okay, a circle has a diameter of 20 centimeters, so I'm going to draw my circle. Diameter of 20 centimeters. What is the area of the sector bounded by a 208 degree major arc? Round your answer to the nearest thousandth. Alright, so let's say that I have a 280 degree major arc. Oh, 208. Sorry. Okay, if I were to do the central angle, what would I have left in my little piece here? 152, and then that means that this angle here, because it opens up to that major arc, would be 208 degrees left. Okay, so we want to know the part, all of this. Okay, so is our central angle in degrees or radians? Degrees. Okay, so again, I'm going to have 208 over 360 times pi r squared, and what's my radius? 10. Okay, so 10 squared is 100, so I have 208 over 360 times 100 pi. And because it says to round to the nearest thousandths, do not leave your answer in terms of pi. If it wanted it in terms of pi, it would say leave your answer in terms of pi. Let me know what you get.
21.51
Very good. 181.514. And units is huge because you're dealing with area. Centimeters squared. Okay, number 2. One slice of a 16-inch pizza is missing as depicted in the diagram. What is the area of the remaining pieces? So the shaded part. Round your answer to the nearest tenth. Okay? So what would be our central angle that represents the shaded part? 330. Do we agree? Okay, 30 degrees does not represent the shaded part and what we're trying to find. Okay, so you have 330 over 360 times pi r squared. What's our radius? 8. So 330 over 360 times 16 pi. This time you have to round to the nearest tenth.
64 pi.
Oh, sorry. Thanks. Time we are in. Okay, next one. Find the area of the shaded part of the circle. How are we going to find the area of the shaded part? Yes.
Find the sector fraction and then subtract the area of the triangle.
Very good. So you're going to have area of the sector minus area of the triangle. Okay? 1/2 base times height. What's your base and your height? 8 and 8, because that's just another radius. So 1/2 of 64, and you get, okay, 32 units squared. Okay, now we need to figure out the area of the sector. What is the central angle? 90 over what? Times what? Pi 8 squared. So 1/4 times 64 pi. Don't round it. Leave it in terms of pi.
Oh, okay. 16 pi.
16 pi. Okay, so we have area of the sector, and now we need to subtract the triangle. So you can do it 2 ways. You can convert it as a decimal and leave your answer as a decimal, or you can leave it in terms of pi, and it would just be 16 pi minus 32 units squared. Or if you give me the decimal answer, take,
50.2.
what is it, 50.26?
50.26.
Did you minus 32?
No.
So to do that, you just multiply 16 times pi.
18.227.
18 point what? Okay, so that's if you leave it in terms of pi, and the other one is if you leave it as a decimal. In your skills check and test and homework and all that, it'll tell you. If it doesn't tell you, leave it in terms of pi, because when you leave it in terms of pi, you're not doing any rounding, so your answer is exact. If you start rounding, okay, that's not what the directions tell you to do. Okay, number 4 says find the perimeter and the area of the shaded region. That's fun. How would you find the perimeter?
Circumference.
What was that called last class, though?
Radius.
Arc length. Very good. So you're going to have arc length plus your two sides. Okay? Let's find the arc length first. How do you do that?
Oh, we do something divided by radians thingy.
This divided by 360 and multiplied by what? 2 pi r. Okay, what is your central angle? 90 over 360 times 48 pi. So what is the area of that arc length? What was it? 12 pi. So if I want the perimeter, what would be the perimeter? And you can just leave it in terms of pi. pi plus 48. Very good. Okay, if you converted to the nearest hundredth, what would that be?
What is the plus 48?
Because it's the perimeter, so 24 plus 24 plus that.
Okay, so we found the arc and then we were adding that.
Okay, so if you wrote this as a decimal, what would it be to the nearest hundredth? Okay, now we need to find the area of the shaded region, so how do we go about doing that? What's our biggest shape in this picture? The square. Okay, so you have area of the square minus what? You're looking for the shaded region. Minus the sector equals the shaded region. Okay, so let's look at the area of the square first. How do you find the area of the square? 24 times 24, which is 576 units squared. Okay, now we got an area of the sector. What's my central angle? 90 over times what? Pi r, which is 24 squared. Leave it in terms of pi. Oops. Yes. Okay, so if you wanted to leave it like that, you could. 576 minus 144 pi units squared. Or if you convert it to a decimal, what would you get to the nearest hundredth? 123.615. Very good. Okay, so do you see how you had to know last class and today? Okay, so arc length and sector area look very similar, except for remember, arc length is a part of the circumference. So when you take your central angle over 360, you have to multiply it by your circumference formula because it's part of the circumference, whereas sector area is part of the total area, so you're taking the angle over 360 times pi r squared because you're dealing with area. Okay, so for arc length you're dealing with circumference, sector area you're dealing with area. Okay. Number 5, find the area of the shaded part of the circle. After solving this, how will your method change if the arc measure is 86 instead? Okay, what do you know about our central angle?
60 degrees.
60 degrees. Okay, so how can we go about solving this? Or what do we need to do?
Oh, we can do straight to find out the other side of the triangle.
How do you figure? How do you know? Okay, but what... Okay, before we start looking at, like, the logistics of it, how do you find the area of the shaded part?
Area of the triangle, sorry, the whole thing minus...
Sector minus... what? Triangle. Okay, let's look at the sector first. Okay, I'm going to have theta over 360 times pi r squared. So I have 60 over 360 times, what's our radius?
12.
24 pi. Okay, currently I have 60 degrees and I know that all my sides are 12. How do I find the area of this? Do you have a question, Alex?
No.
Oh.
90, 30, 90.
It's a 30, 60, 90 triangle if you drop the height, and you have to have the height in order to find the area, because it's 1/2 base times height. So, she's exactly right. When you bisect that top angle, you're creating that 30, 60, 90. Okay? Across from 30 is what rule? X, which in this case is 6. And then across from 90 is 2x, which is 12. And what goes across from 60? X radical 3. So, what is our height? Very good. So, our base is 12. Our height is 6 radical 3. Okay, so when I take 1/2 base times height, the area is 62.35, you said? Okay, so you have 24 pi minus 62.35. Go ahead and convert this into a decimal as well, since you made a decimal here. What do you get? What is it?
Oh, if you subtract, you get 30.04. Oh, 13.04.
I'm hearing all different answers.
Okay, if you subtract that, you'll get 13.04.
13.04. Listen, if I told you to leave this exact, which is no rounding at all, how do you write this without rounding to the nearest decimal? Hmm?
6 times 6. Oh, you did 72.
Which is what? Right. Very good. So if I wanted the exact answer, it should be 24 pi minus 36 radical 3 units squared. That's exact. That's rounded.
How do I know that the third side was 12?
Because if this is 12 as well, now you have an isosceles, which means the angles have to be distributed evenly between these two.
Okay.
And there's 120 degrees left because this is 60, so that makes these 60 and 60, which in turn is the equilateral.
Why is it 36 radical 3?
Because 6 times 12 is 72, divided by 2 is 36. Okay. Yay, 30, 60, 90. Everything coming full circle. No pun intended. Okay, find the area of the shaded region. How do we do this?
Subtract the triangle from the circle.
Okay, sector minus triangle. Okay, in this case our sector is a semicircle. Okay, so we're going to have 1/2 times pi r squared. What's our radius? Okay, so what's the area of our sector? 50 pi. Okay, our triangle is what kind? A 30, 60, 90. Okay. So I need my base and my height. Right now I only have my hypotenuse. So what's my base? So across from 30.
10.
X, which in this case is 10. Because you have 2x right here representing 20. Okay, which makes our height what? 10 radical 3. Okay, so I have 1/2 times base times height. Okay, leave it exact for me.
2 radical 3.
Okay, so now somebody give me it rounded to the nearest hundredth.
70.4814.
If you wanted it to be rounded, that would be your answer. Okay, so look for those 45, 45, 90s or 30, 60, 90s.
Can I see the previous question?
What if they didn't tell you that that was a right angle? What if this wasn't here?
Oh, we know that. No, fine.
Oh, then it's an inscribed angle,
Yeah.
and then the outer, it should be half of the arc that is also substitute.
180 and then, okay.
Okay, remember we had that lesson with the triangles, that if if a triangle is inscribed in a circle and one of the sides represents the diameter, then it is a right triangle. Okay, so that was on our lesson, I think 12.1. Okay, number 4, find the area of the shaded region. How do we do this? Sector minus triangle. What's different in this one? It's in radians.
Okay, this is over 2x, 13, fine now. We're good.
Okay. So, to find the area of the sector, you have pi divided by 3 over 2 pi times 144 pi, because it's 12 squared. How do you get a fraction, how do you get rid of this 2 pi denominator? What? You multiply by the reciprocal. Remember, that's like saying 2 pi over 1. So that becomes pi over 3 times 1 over 2 pi. Yes?
The second step for radians, we could just do the theta times radius, because the 2 pi's cancel.
But it's not substitute.
That's for arc length.
What is the second?
We're doing sector.
Oh.
That was last class. It's simplifying this fraction. When you have a fraction and a fraction, you multiply by the reciprocal of the denominator. Okay, so your pi's cancel. And what are you left with? 1 over 6 times 144 pi. So what is the area of the sector? 24 pi.
Why didn't you just go by radians?
What? I mean, you can.
How do you split
1/6 by what? You got it? Okay. So we need to figure out the area of the triangle. How can we go about figuring out the area of the triangle? How do you know it's 30, 60, or 90? I don't have any angles right now.
Oh, because you change the size opposite and the radians to degree is what?
Convert your radians to degrees real quick. So pi over 3 times 180 over pi. So what's your angle? 60. So if you wanted to do that from the beginning and use the other formula, that's fine.
Can you show us that?
Show us what?
And you can do the reference.
It's from last class, conversions. Okay, so we already did this 30, 60, 90 with a side length of 12. So who remembers, or just flip over, what was the area of the triangle? What was it? 36 radical 3? Yeah. Okay, so you have 24 pi minus 36 radical 3. That's exact if you round it to the nearest. Let's go 100th. What do you get? 13.04 units squared. So the point of this problem was to see it done in radians because it's the same exact problem as 5. Just 5 was with degrees and this one's with radians. And this is probably the most tricky part because people don't know how to simplify this. Okay, so you easily could be given something in radians.
So how do we simplify that again? We just break it and
You multiply by the reciprocal of the denominator. Or you can just change it to degrees and use the other formula. Okay. What?
what do we change? Oh, instead of dividing by 2 pi, we just convert pi over 3 to degrees.
And then you could have used the angle over 360 times pi over 3. Okay, again, if you don't like example 4, then just do it like the number 5 on the other page. It's the same thing. Okay, example 5, find the area of the shaded region. What do we do? Find the area of the circle. Then what? Subtract the sector. So far we have just this. But I want the shaded part, so what else do I have to do?
Subtract the triangle.
So right now I have the circle minus the sector. So I have what's shaded in blue, but I want the whole shaded area in gray. So what do I need to do?
Add the triangle.
Add the triangle, because I need to add this shaded part.
Basically, we're doing sector plus triangle.
No, yes. Well, area of circle minus
Minus
sector
sector
plus triangle. Okay, so area of my circle is what? Pi r squared, and what's my radius? So the area is...
36.5.
Okay, my sector. I have theta over 360 times pi r squared. What is my central angle? I'm looking at just my sector. What's my area, or my central angle of this sector?
60.
60. Okay, and then I need my triangle. Okay, what kind of triangle do I have? So right now I have 6, 6, and 60 degrees. An equilateral, same thing. You've got 120 degrees left in those base angles, making it an equilateral triangle. Okay, so I'm going to redraw it so that it's bigger. Okay, what goes across from 30? X, in this case it is 3, making my height 3 radical 3. So to find the area of my triangle, I have 1/2 base times height, 1/2 of 6 times 3 radical 3. Okay, so let's go through and put everything in exact value. So in terms of pi and radicals and all that. So 36 pi minus, what is my area of my sector? 6 pi minus, leave that in a radical, what do you get? 9 radical 3. Okay, one more simplifying step. Huh? Oh, plus, sorry. And my last step is combining my pi's. What do you get?
30 pi.
Very good. 30 pi plus 9 radical 3. And to the nearest 100.
109.84. Did we get 6 pi for simplifying sectors?
Yes.
Oh, no.
Okay, questions. That problem is important. Questions, questions, questions.
Oh my god.
Okay, next one. Find the area of the shaded region. How do I do that?
Oh my god.
Find the sector. Two sectors. Area of two sectors. Area of the circle minus the
Wait a second.
area of two sectors.
And we know that that's the
Just
first
add,
line.
find the two sectors and add them.
Can we just combine the sectors if we know they're equal to the first?
So how do we do it?
Oh. Well, that's the question.
So you're multiplying what times 2?
40 degrees.
No.
So,
40 divided by
180
Guys,
minus
stop
40.
giving me numbers. I'm just trying to get the words out first. You're taking 2 of what?
Sector.
Thank you. Okay, now I'm substituting into my formula. Okay, what is the central angle associated with my sectors? 140. How do you know it's 140?
180 minus 20.
Right, because these two are supplementary. Okay, so I have 140 over 360. What's my radius? 6. So I have 2 times 140 over 360 times 36 pi. Leave it in terms of pi.
Pi if you multiply by 2.
28 pi. Oops, meters.
If they don't tell you if they want you to leave it pi or not, even do decimal or pi, right?
No. Guys, if they do not tell you to round, then you don't round. You should always have the exact answer unless it physically tells you round to the nearest x, y, or z. Okay, last one. Okay, find the area of the shaded region below. How do we do that?
The area square.
Square minus what?
Minus 4 times circle.
Very good. Square minus 4 circles. What's the length of our square? 16. How did you get 16?
The radius of the, yeah.
Combine all your radius. Okay, so you have 16 by what? 16, because it's a square. Okay, then you have 4 times pi r squared, and what is our radius? 4, so 4 squared is. Okay, what's 16 times 16? 256 minus 4 times 16 pi, which is 64 pi, and then you would just have feet squared.
Oh, I like this one.
Because they don't ask you to round.
Very, you know.